subtracting, we have to do similar things. Like we still have to factor a little bit because we have to see what the denominator is made up of. So before we do like this, I'm going to just quickly talk about something like this. All right, so when we add regular fractions, we need a common denominator. And so in this situation, we would multiply this fraction by a 2. Now, whenever we multiply the denominator, we also multiply the numerator. Do we know why?
Chicken thigh.
But why?
Because you have to keep it the same.
Because we're not allowed to change the value of this fraction. We're just allowed to change what it looks like.
You change the
And so by multiplying by the fraction 2 over 2, we're really just multiplying by 1, and therefore it doesn't change the value, it just changed what it looks like. Now, over here we would multiply by 3 over 3. Okay, we usually put these two multiplication signs here, but really what we're doing is we're just doing this. Just so you know. And so that would change this to 2 over 6 plus 3 over 6. And then what happens after this?
You can add them now. 2 to 5 over 6.
So you're saying I don't cancel or anything?
No.
No, you just add them. So what's the purpose of finding the common denominator?
So you can add them correctly.
So you can add the numerators. So we add the numerators, and then what goes down here? So it doesn't become a 12 or a 36.
No.
Okay, I just want you to remember these things. Because it sounds like common sense, then when I put letters in it, you guys do stupid stuff. Yes, so the purpose of finding a common denominator is so we can add the numerators, and then we put the answer, added numerators, over common denominator. Now, in the event where we get something like this,
There's your word.
sometimes we can then simplify again, right? And so we would like divide by 3 and we get 5 over 2. So sometimes after we add the numerators, we can simplify. And it's going to be the same with these. So what we're going to do is find a common denominator, add the numerators, get a fraction, and then sometimes you'll be able to simplify your answer, but not all the time. In order to find a common denominator, we have to know what comprises the denominator, so that's where the factoring comes in. So if there's something factorable, we factor it. So this second fraction, I should be able to factor this.
X minus just plus 1.
Yeah, good job. Now if you can't factor it, then
That
you
sucks.
just leave it. Yeah, it sucks. Just leave it.
It's tough.
It's tough, boys.
The whole purpose of doing that is so that we can see like the pieces of the denominator so that we can find out what a common denominator would be. So they both have the x minus 1 in common, but this one has an x minus 2. This one doesn't have the x minus 2. And it needs to have the x minus 2 so that their common denominator can be x minus 2, x minus 1.
X minus 2 the bottom and the top.
So we're going to multiply by x minus 2 on the bottom and on the top. So the numerator of this fraction becomes x squared minus 2x when you multiply, aka distribute. In the denominator, I'm not going to multiply, I'm just going to write x minus 2, x minus 1. You're going to add this here. So now that we have a common denominator, we will add the numerators.
I don't know if I necessarily like this.
Sorry.
That sucks, man. X squared
Okay,
minus
so you're
1.
adding your numerators. I'm going to show you something with, so you're taking this binomial and you're adding it to this binomial. In the event that this is a subtraction sign, you want to make sure that you distribute. Since it's just an addition sign, we don't need these parentheses. But if it's subtraction, we do want the parentheses. So parentheses optional. All of this is over our common denominator. Just one denominator, not 2.
Well, it's a common denominator, so
Now, in this numerator, we can combine the negative 2x and the 2x, and that would make just 0. So we're left with x squared minus 1 over x minus 2 and x minus 1. So we added the numerators.
I have been fine with it.
Now, sometimes, after you add the numerators, you can simplify. You may or may not be able to tell if you can simplify. And so after you combine, you're going to try to factor again.
So can't you get a 1?
X squared. It'd
We
be
can
X minus
factor
1.
the
X
difference
It'd be
of
x
squares.
plus 1, x minus 1.
Yeah. Oh, I see what you're saying. So
Mean.
then, yeah.
plus-
Now after we
Cancel.
factor, you can see that we'll cancel these guys. So you wouldn't have seen that until you factored. So basically after you combine, you're gonna factor again, just in case, and then simplify if possible. So we can. So we get x plus 1 over x minus 2, and that would be our answer. Now, if asked for restrictions, okay, your denominators of the original are your restrictions. So if you look denominator, we have a 1 that would make that denominator 0. That would be bad. We don't want to divide by 0. So 1 would be a restriction. Here 2 would be a restriction, and here 1 would be a restriction, but we already talked about that one. So you have 2 restrictions. X cannot be 1 and x cannot be 2, because if x is 1 or 2, we're creating denominators of 0, and we're not allowed to do that.
Wait, so you look at the restrictions for the, like the, not your final answer?
Like your factor, yeah, correct. Like your factored, like the, basically like the first step after you factor.
Mm.
So if you want to do the restrictions at the beginning, maybe, so you don't forget, or you don't do the wrong one, maybe that's a good idea.
So it would just be 2 and negative 1.
Alright, so step 1, factor. Step 2, find common denominator. Step 3, add numerator. Step 4, factor again. Woo. Step 5, simplify. These last 2 steps are sometimes not necessary. Asterisk.
They're optional.
Optional. Well, not optional. Like, if applicable.
There we go.
Yeah. So for the U-try, this first one we're gonna factor out an x, the greatest common factor,
Be quiet.
and so you can see that this fraction is missing the x, so we're gonna multiply the first fraction by x over x. Now, when you multiply x times a binomial, you have to distribute it. So that's gonna become x squared plus x on the top there. Now the whole purpose of finding a common denominator is so you can add your numerators. So we're gonna add x squared plus x, and then add the negative 2, which is just minus 2. Look at this. Possibly we're done, possibly we're not. We're gonna attempt to factor. If you can't factor, then you're done. But this does factor.
So it'd just be
to
negative 1 and 2.
x plus 2, yeah, and x minus 1. Now, just because you can factor doesn't necessarily mean that you can simplify either. So sometimes you can factor, but it won't simplify. That's not this case. So here we can cancel an x minus 1. And so what we're left with is x plus 2 over x. And that is your final answer. You cannot cancel the x's. Now, your restrictions. Restrictions we're gonna get from the original place where we factored. So a 1 would make that denominator 0, so x cannot be 1. Now, what would make this 0 if we plugged it in for x here? 0. So x also can't be 0. So you have just a plain x in your denominator, then x cannot be 0, is one of your restrictions. And that's it.
Indubitably.
This first fraction, you'd have to multiply by 2, because this fraction has a 2 in its denominator and this fraction doesn't. So you're going to multiply by 2. And then the second fraction doesn't have this extra x, so we're going to multiply by x. Okay. So numerator here becomes 2x plus 4 over my common denominator. This numerator becomes x squared plus 2x over common denominator. Now, with addition, you can just kind of like add everything, it's super easy. With subtraction, you want to be careful. So you're taking 2x plus 4 and you're subtracting the quantity x squared plus 2. So you're subtracting both the x squared and the 2. So I put parentheses around that so I can remember to distribute the negative sign. If you don't put parentheses around it, you're going to wind up only subtracting the x squared and not both the x squared and the 2x. Anytime you have subtraction of multiple terms, you have to put those in parentheses, okay? Because if you don't, you're not going to distribute the negative sign, and you won't wind up subtracting all the terms. You're just going to subtract the first term, and that's wrong. You need to subtract everything that comes after the minus sign. So this is 2x plus 4 minus x squared minus 2x.
What the fuck balls?
What?
This is going to take up more space.
Okay. I hope I answered right.
Okay, we get it. You already did it.
So simplifying, the 2x and the negative 2x would make 0, so I have 4 minus x squared over 2x times x minus 2. And then that actually you can factor. So we did some of these in the last section. We can factor out here a negative 1 to make it go the other way. And then now we have a difference of squares. So that would give me x plus 2 and x minus 2. And that will allow the x minus 2's to cancel. And so our final answer is going to be negative x minus 2 over 2x, because I multiplied the negative 1 by x plus 2. Or you could do like Emma, you were saying, you could like put it out in front like this.
I'm just leaving it out because I ended up confusing myself. And it's not worth it. I'm just gonna leave it and make it look weird.
Wait, does that? Okay.
So you want to make sure that you combine all your numerators completely, and then only after you've done that, then you can maybe factor and cancel.
Why did I just do that?
Alright, so factor, multiply the first fraction by x minus 1, and then you need to FOIL out these two binomials. So when you do that, you get x squared plus 2x minus 3, all of that over your common denominator. Okay, so now you need to subtract x squared plus 2x minus 3 minus 6x and then negative 7. So that's going to make that a positive 7. So distribute your negative sign. Combine like terms in the numerator, so you get x squared minus 4x plus 4, which factors, so you can keep going, so factor the numerator. And you can see that 1x minus 2 will cancel. And we get x minus 2 over x minus 1. Ta-da! And if asked for restrictions, we're looking back up here for the restrictions. So x cannot be 2 or 1, because those values will make the denominators 0. So the restrictions are really important when we solve equations, you'll see, because they'll make a solution extraneous, possibly. So that's why we're like practicing them now. Also, they're super important when we're graphing, because they make holes and asymptotes. So So again, that's why we're mentioning them.